let me tell you my plans for the day. If you were here, I would give you back your test and let you look those over. Overall, I was very, very pleased with our Chapter 3 test. Here's where I need to take you today. I need to introduce you to what's called the power rule. Basically, here's where I got to start today. Remember all of that limit as h approaches 0 of either f of a plus h or f of x plus h minus f of a, all of that? We're going to do away with that today. Why did I make you learn that in the first place? What I need you to remember is the derivative. Whenever we say the derivative, it's the instantaneous rate of change, but it's also the slope of the tangent line. And the reason all of that works is because the distance between my x values gets smaller and smaller. That's as h approaches 0. So that's why I had to do all that to you. But as we go through the day, we're going to eliminate this and try to get you good with the shortcuts. So hang with me on this. If you have any questions, please come in and let me clean it up. But hopefully you have your notes in front of you. I'm going to click right along with them. If you don't have your notes in front of you, no big deal. Just kind of watch and learn. So here goes. Here are some things that I made up. These are some questions that we've done throughout the Chapter 3. I'm going to tell you that f of x is 3x squared plus 2x minus 5. Hey, check out what the derivative is. The derivative of that is 6x plus 2. I want to point something out here. I'm going to find the derivative of 3x squared, and it must be 6x. So check this out. To find the derivative of 3x squared, I'm going to bring down my power, which becomes a 2 times 3 x to the, and you're going to take away 1 from the power. I don't know if you remember from when we graphed the derivative, when we graphed a 4th degree equation, its derivative was a 3rd degree. When we did a parabola, a 2nd degree, it was a 1st degree. So notice that this 2 times 3 is 6, 2 minus 1 is 1. And now let me pick on 2x. Think about the line y equals 2x. No matter where you are, the slope of that line is always 2. Also, think about this. This is really 2x to the first power. I'm going to bring down the 1. 1 times 2 is 2. X to the 1 minus 1. That gives me 2x to the 0, which is really just 2. Don't worry, I'm going to give you a formula here in a little bit. Hey, now think about this negative 5 here. If I gave you the line y equals negative 5, that line right there, think about this. What's the slope of this line no matter where you are? Well, the slope of this line is always 0. So really there's a plus 0 out here to match up with that negative 5. So there's kind of the derivative rule. We're going to clean it up here in a little bit, and I'll give you a note card next time I see you, and you can write the power rule on it. So check out this one. 1 half x squared plus 6x minus 2. We're at the point now I want you to just be able to look at that and know the derivative. The derivative is 1x plus 6. Picture this again. 2 times 1 half. 2 times 1 half is 1. X to the 2 minus 1. So all of that simplifies to x to the first. Look what I got right there. The slope of the line y equals 6 is always 6. The slope of the line y equals negative 2 is always 0. So there's the derivative. Here comes your next one. X cubed plus 3. That derivative is going to be, bring down that 3, x to the 3 minus 1 is 2, and the slope of the line y equals 12 is 0. Hey, check out this derivative as it comes up. F prime of x is 3x squared. Notice my notation as I went though. Here's my fourth one. How about this 2x to the 1 half, or 2 square root of x? You've done this problem on a quiz. its derivative is 1 over the square root of x. Here's how come. I'm going to think of this as 2x to the 1/2. What happens if I bring down the 1/2? So I got 1/2 times 2, which we know is 1. And I've got x to the 1/2 minus 1. Well, 1/2 minus 1 is negative 1/2. So there's that piece. Math Excel accepts negative exponents. I don't. So get rid of that negative exponent. So you could either see it as x to the negative 1/2, or you could also see it as 1 over x to the 1/2. Same thing. And I think I have one more coming your way. 2 over x. Some of you have this one memorized already. You know it's negative 2 over x squared. So there's the derivative of it. But here's how come. I'm going to think of this as 2x to the negative 1. I'm going to bring down that negative 1. So I've got negative 2x to the negative 1 minus 1 is negative 2. So there's where I got my negative 2 over x squared. That's our shortcut to the derivative. The key thing today is being able to manipulate things. So if I was there, you would have a note card. But here's the formula that I need you to know. The derivative for the power rule, which I think I have on the next slide. Yep. If you have the power rule, here's the derivative of it. And here's how I'd like for you to write it on a piece of paper real fast. If you're given f of x equal x to some power, then its derivative, f prime of x, is, bring down the exponent, times x to the n minus 1. So write this down somewhere, if you will. If I give you a note card, you can put the power rule and put that on there. I went ahead, our book doesn't do this, but I went ahead and just one up there. If there's a constant in front of that, you'll find as we do work with our constants, you can move those inside, outside, upside down, it doesn't matter. So its derivative is going to be whatever your constant is, times, bring down the exponent, x to the n minus 1. I've got some coming your way just to get you good with them. The hard thing with the video is I can't look in your eyes and see if I think you're getting it or not. So hang with me. You can hit pause, whatever you need to do. But I'm finally to your note sheet. So here goes. I'm going to tell you that f of x equals x cubed. We had graphed something like this before. Remember, its derivative is going to look something like that. Now here goes. If f of x is x cubed, f prime of x is going to be, bring down the 3. So I've got 3x to the 3 minus 1 is 2. I'm done. There's an equation that will give you the slope of the tangent line wherever you want to find the slope of the tangent line. Here goes the next one. F prime of x is going to be, you don't realize it here, but we're finding 1, 2, 3, 4 derivatives and adding or subtracting them together. So the derivative of 2x to the 4th, bring down the 4. 4 times 2 is 8. X to the 4 minus 1 is 3. Minus 3 times 2 is 6. X to the 1st plus 6. And the derivative of 7, the derivative of a constant, is 0. The reason being, the slope of this line right here, the slope of the line y equal negative 7 is 0. So that's why there's nothing there. So there's the derivative. There is an equation that will give you the slope of the tangent line anywhere you want to know. How about 5 over x? Here's what it's not. Here's what it's not. It's not 5 over the derivative of x, which is 1. It's not that. I have a special rule called the quotient rule for that. Here's what you got to do. Rewrite this where it's x to some power. So notice, guys, f of x, f of x. My notation hasn't changed. I'm not finding the derivative yet. I'm going to think of this as 5x to the negative 1. Now I'm ready to find the derivative. So hence the f prime of x. The derivative of this, bring down the negative 1. So I got negative 5x to the negative 1 minus 1 is negative 2. Math Excel accepts negative exponents. I don't. So get rid of that negative exponent. Here's our answer. Negative 5 over x squared. Done. A lot faster than our f of x plus h formula. But the key thing, guys, write it as x to some power. Here's your 4 over x squared. I'm going to rewrite this as 4x to the negative second. Now I'm ready to do the derivative. F prime of x is going to be, bring down the negative 2. So I've got negative 8x to the negative 2 minus 1 is negative 3. That makes my derivative negative 8 over x to the third. Got it. The slope of the tangent line, wherever I want to look, is bound by that right there. Here comes another your way. F of x equals 6 over x to the negative third. I got to write it where it's x to some power, so f of x equals, hey, I want to get rid of that negative exponent, so I'm just going to bring it up. It was negative, since I'm bringing it up, now it's positive. Now find your derivative. So I got f prime of x equal 3 times 6, 18x to the 3 minus 1 is 2. Got it. Here comes 5 over 2x cubed. I'm going to show you an error that happens all the time, or just kind of point something out. Hey, please note, the exponent with the x is a 3. The exponent with the 2 is a 1. When I rewrite this, I don't want to bring that 2 up. If I do, I'm going to have a 2 to the negative 1. So when I rewrite this, I'm going to rewrite it as this. 5 halves x to the negative third. Leave your 2 in the denominator. That's no big deal. Now I'm ready to find the derivative. So I'm going to bring that negative 3 down. So 5 halves times negative 3, so I got negative 15 over 2, x to the negative 4th. Since I have a negative exponent, I'm going to bring it back down to the denominator. So I got negative 15 over 2x to the 4th. There's my derivative. Hey, but notice again, guys, the key is write it as x to some power. That way we can apply what's called the power rule. The power rule is the basis of everything that we do from here on out. Here comes the same problems. I'm just going to switch notation on you. Notice that this is y equal 7 over the cube root of x. I'm just going to rewrite this first, though. So this is going to be y equal 7 over x to the 1/3, which is really y equal 7 x to the negative 1/3. So I brought it up so that I can find the derivative of it. Okay, now here comes some notation for you. Well, although it was easy to put f prime of x, let me show you what this notation looks like. Whenever you see d dx, that means you're finding the derivative of something. X tells you the variable that you're working with. Whatever's right here tells you the name of the function you're dealing with. So if you see dy dx, here's what it really means. You're going to find the derivative of the function of y, and the variable that you're using is an x. If there was a t here, there'd be a t right there. That's all it means. So now I'm going to go ahead and use the power rule to find this derivative. So I'm going to have dy dx. The derivative of y with respect to x is, bring down that negative 1/3, so I got negative 7/3 x to the negative 1/3 minus 1 is negative 4/3. So my final answer, dy dx equals negative 7/3. I'm going to put this in the denominator as x to the 4/3. And then I got it. There's my answer. On to my next one. Y equal 5 over 2, quantity 2x to the third. If you can simplify first, simplify. So this is going to become y equal 5 over 8x to the third power. Now let me write it to where I can find the derivative. So notice I still have y equal. I'm going to think of that as 5/8 x to the negative third. Now it's in the form I can use the power rule. So here goes dy dx. The derivative of the function of y with respect to the variable x is, bring down the negative 3. So I'm going to get negative 15/8 x to the negative 3 minus 1 is negative 4. Since we just said negative 4, I'm going to put it in the denominator. And there's my derivative. My slope of the tangent line, wherever I want to find it. I got a couple more before I switch gears just a little bit. Just some new notation. Math Excel uses this notation every now and then. I hate this notation, so I will never use it. But it's just notation for this. If you see d little x, d sub x, that means you're going to find the derivative with respect to x of whatever's inside the parentheses. One reason I don't like this is the notation is, once you find the derivative, it's going to be d of x equals whatever the derivative is. So I just popped these in to let you see what it looks like. So here goes. I'm going to find the derivative with respect to x of. I need to think of the fifth root of x as something I can find the derivative of. So I'm going to think of it as x to the 1/5. Now this derivative is going to be, bring down your 1/5, so I got 1/5. X to the 1/5 minus 1 is negative 4/5. So my ending derivative, I'm going to have d of x is 1 over 5 x to the 4/5. I just put it in the denominator. Like I said, guys, just another way for notation. What will you see 99% of the time in the class? You'll see an f of x where we get an f prime of x, or you'll see a y to where we get dy dx. That's my main notation that we use. Another one, d of t. Hey, don't panic that we switch letters. That just means the letter that we're using happens to be a t. Otherwise, we're still finding the derivative of it. So, write it as something we can find the derivative of. So I'm going to write this as 1 over 2t to the 2/3, which becomes 1/2 t to the negative 2/3. Now I'm ready to use the power rule. So here goes. The derivative with respect to t is, bring down that negative 2/3. 1/2 times negative 2/3 sounds like negative 1/3. Negative 2/3 minus 1 is negative 5/3. So I'm going to just put t to the 5/3 right there. And then we got it. That's called the power rule. If you look at your sheet, I still have some more coming, so hang with me. I'm hoping to be done in about 12 minutes. So look at your next one. Please don't write this down. Let me tell you what it's not. It's not this. It's not the derivative of each of these, 6x squared minus 10x plus 6 over that derivative. It's not that. I have a special rule for quotients down the road when it doesn't work. Here's how we handle this. If there's a monomial in the denominator, we're going to reduce first. So I'm going to think of this as, I'm just going to write it once. I'm going to think of this as 2x cubed over x minus 5x squared over x plus 6x over x. I could do that if there's a monomial in the denominator. So here's what f of x is. 2x cubed over x is 2x squared. Negative 5x squared over x is minus 5x plus 6. I just simplified f of x. Now I'm ready to do the derivative. The derivative of this is going to be 4x minus 5. And we got it. Let's simplify first. And normally, guys, I won't write it like that. I'll just say 2x cubed over x is 2x squared. 5x squared over x, negative 5x. 6x over x is 6. Here goes your next one. We're going to simplify it first. So f of x equal 3x to the fourth over x squared is going to be 3x squared. Negative 7x cubed over x squared is minus 7x. Okay, now check this one out. 12 over x squared. I'm going to scribble that down here. 12 over x squared. You want to write that to where you can find the derivative of it. So I'm going to think of that as plus 12x to the negative second. So I just rewrote it. Now, go find each derivative. So wait. So the derivative is going to be, the derivative of 3x squared is 6x. The derivative of 7 is negative 7. Be careful here. The derivative of 12x squared, or 12x to the negative second, bring down your negative 2 is negative 24x to the negative third. So I've got negative 24 over x to the third. But be careful. A lot of times people do this and it's wrong. They say it's going to be negative 24 over x to the third. That's wrong. The only thing that gets the x to the third is this last term. So there's my answer. Another way you might see the answer, you might see the answer as that with a common denominator. Well, if you do, then you might see there's a common denominator of 1. You might see 6x to the fourth minus 7x cubed minus 24. Either of these answers will be correct. Math Excel accepts that. If it's a book assignment, sometimes they do this. So I just need you to be able to recognize which one it is. And just a handful more, so hang with me. Here's the same problem that we did on a worksheet. We're just going to do it a lot simpler. Given f of x equals 3x squared minus 4x plus 2, find f prime of 3, and then write the equation of the tangent line at that point. Well, here goes. I'm going to find the derivative of it, which tells me the slope of the tangent line wherever I want to look. Well, that derivative looks like 6x minus 4. I want to know what the slope of the tangent line is at 3. So let's find f prime of 3, and that's going to be 6 times 3 is 18 minus 4 is 14. So right here is the slope of the tangent line. So I know my slope. I know my x value is 3. I need my y value. So I'm going to plug 3 into the original equation. And if I plug 3 into the original equation, I'm going to get 17. Now we're ready to write the equation of the line. Y equals mx plus b. Y is 17. M is 14. X is 3. So that looks like 42. Plus b. Looks like b is going to be negative 25. So the equation of the tangent line, y equals 14x minus 25. And then we got it. So just like we did before, we're just getting it quicker. Look at your next example if you would. It says find all points on the graph where x cubed minus 5x squared plus 6x plus 3 has a horizontal tangent line. Hey, here's what we're looking for here. Think about this graph. It's some cubic. I have no idea what it looks like. But it's some cubic. We're trying to figure out where that cubic has a horizontal tangent line. So I would like to find that point and that point. So think about this. The slope of these lines would have to be 0. So I'm going to find the derivative of this. The derivative of x cubed is 3x squared. The derivative of negative 5x squared is negative 10x. The derivative of 6x is positive 6. The derivative of 3 is 0. Keep in mind what this tells you. This equation tells you the slope of the tangent line wherever you want to find it. So I want to know where the slope of the tangent line is 0. So I'm going to go 0 equal 3x squared minus 10x plus 6. I would normally factor this, but it doesn't factor. So I'm going to grab my calculator, use the quadratic formula, and when I do that, I got that x is going to be about 2.55, and x is going to be about 0.78. So I know when x is about 2.55, I'm going to have a slope of 0, and when x is about 0.78, I'm going to have about a slope of 0. So not a terrible graph, we're just guessing. But as soon as it said horizontal tangent line, you had to think what the slope would be. That means the slope of the tangent line is 0. So there's where we are so far. Let me take for a trip down memory lane. Marginal cost. Hopefully as you've gone, hey, another name for marginal cost would be the derivative. Another name for marginal cost would be the instantaneous rate of change. Another name for the marginal cost could be the slope of the tangent line. All of these mean the same thing. So here's how we're going to attack this problem. Suppose that the total cost in hundreds of dollars to produce X thousand barrels of a beverage is given by that equation. Find the marginal cost at 5. Well, here's what I need to do, guys. I need to find the derivative of the cost equation. Well, the derivative of 4x squared plus 100x plus 500 is simply 8x plus 100. I'm now going to find C prime of 5. And if I do that, plug in 5, 8 times 5 is 40 plus 100, I'm going to get 140. Hey, we've done the math part of it. Now here comes the hard part. What the heck does that mean? If you look back up here, it's our cost in hundreds of dollars, so it's going to cost me $140. Well, that sounds bad to say, so really that's $14,000. It's going to cost me $14,000 to produce the 5,000 barrels. That's what that part means. It'll be a little clearer on my next example. So last but not least, because I'm not going to do that last one. I'll clean that one up in class when I see it. So here's my last one. An analyst has found that a company's cost and revenue equations for a product are given by those two equations. So part A says, find the marginal revenue equation. Well, so on A, guys, to find the marginal revenue, I need to find the derivative of the revenue equation. So I'm going to work with it down here because I can erase it here in a second. So to find the derivative of that, well, the derivative of 5x is just 5. So I'll take care of that one. And there's a minus sign. Okay, to find the derivative of x squared over 1,000, I'm going to think of this as 1/1000 x squared. Bring down your 2, so I've got 2 times 1,000. X to the 2 minus 1 is 1. And 2 over 1,000 reduces to 1 over 500. So there's my revenue equation. 5 minus 1 over 500x. So there's my part A. Part B says find the marginal cost. So I'd like to find C prime of x. Well, if I find the derivative of 3x plus 5, it's just simply 3. What does that mean? It means it costs $3 to make every unit, no matter what. That's what that part means. Here goes my part C, the profit equation. Hey, for a trip down memory lane, remember that the profit equation is the revenue equation minus the cost equation. So my revenue is 5x minus x squared over 1,000 minus my cost equation, which would be minus 3x minus 5. And if I simplify that, it looks like my profit equation is going to be 5x minus 3x is 2x minus x squared over 1,000 minus 5. There's my profit equation. And then last but not least, I meant to have the marginal profit at x equal 4. So I haven't finished my part D now that I look at it. Let me find the derivative of this. So I need to find p prime of x, the derivative, since it was marginal. The derivative of 2x is 2. The derivative of x squared over 1,000 we did earlier, it's right there, minus 1 over 500x. And the derivative of 5 is 0. So there's an equation for the marginal profit. Let me find p prime of 4 then. So I'm going to plug in 4. So I'm going to go 2 minus 1/500 times 4. And I'm going to get something really, really close to 199. Here's what that means. On the 4th unit, and only the 4th unit probably, I'm making $1.99. The third unit and the fifth unit is something totally different. So the marginal profit tells you your cost or your revenue or your profit at that exact unit. So there's where we are so far. I got you on Math Excel. Like I said, I'm going to skip this example for now. If there's one like that on Math Excel, I will get that cleaned up in class. It's one of those examples. It's easier to explain it than explain it on a video. So we'll go there, but I've got you on Math Excel for section 4-1. So if you have any questions, buzz in and I'll get you straightened out. Good luck on my musical people and whatever else you're missing for it. Have a great evening.